Lung nodule detection using machine learning and deep learning and analysis. Cancer is a disorder in which the body cells multiply unchecked. Occasionally, a chest CT scan will reveal a little abnormal location termed a lung nodule, the majority of which are non-cancerous. Only 5% of lung nodules are found to be cancerous. Lung cancer is the leading cause of cancer-related death in both men and women. This promotes the early diagnosis of cancer. Modern methods based on deep learning and machine learning are utilized to find lung nodules. The underlying methods relate to the early detection of lung cancer and have a high specificity and sensitivity for finding malignancy in small nodules. The lung nodule detection technology is presented in this review article in detail. From this review, it is clear that the most popular lung nodule detection systems are deep learning based CNN and machine learning based, namely SVM systems. Hybrid approaches are also popular nowadays. We assess the efficiency of existing state of the art approaches with datasets used, challenges faced, and recommend a path forward for high impact future research. Lung cancer has the highest mortality rate of all cancers. Studies have demonstrated the need of an efficient screening program by demonstrating how early stage disease detection significantly raises the 5-year survival rate. As a pipeline for lung cancer screening, radiologists have been advised to use computer aided diagnosis CAD systems as a tool for lung nodule characterization and malignancy prediction, among other tasks. The use of deep learning techniques has increased due to the abundance of label data. To find nodules, determine their features, and ultimately evaluate where they are cancerous, radiologists use low-dose computerized tomography in clinical practice. These tasks are challenging and have a high observer variability. Radiologists usually rely on well-known nodule characteristics to evaluate whether a nodule is malignant or benign, making the interpretation of malignancy from CT images a difficult and subjective endeavor. Classifying the malignancy of a nodule is a crucial step in the lung cancer screening process since it enables diagnosis development and establishes patient follow-up. Radiologists can review many images and make diagnoses using manual techniques, but occasionally a patient needs hundreds of lung CT images for an accurate diagnosis. Such a method wears out the doctor and hampers judgment, which could lead to missed or incorrect detection in addition to having a low detection efficiency. To help doctors diagnose patients and minimize incidents of this nature, many academics have suggested a CAD system. The standard of CAD inspection system has two obvious shortcomings, despite having delivered excellent results: overall poor efficiency and detection hypothesis and the actual circumstances are highly unlike, which worsen the detection outcome as a whole.
Hello, this is Ashish, and I'll be covering the general architecture. So now uh, we can see this is like the general stages which the learning model has to pass through as we tend to find the data set which is needed. After that, we take the images and give them to the learning model as input. Then we need to pre-process the images and convert them into the required format, and this format depends upon the learning algorithm which we are using, or the image processing techniques which we'll be using to obtain the images in a certain format which could be easily given to the machine learning model for learning, and also to make it possible that the features could be extracted easily. So after this, it passes through segmentation and the feature extraction, where all the required features are obtained from all the training images. And then there's the detection process, which based on the features which have been obtained from the images. Based on these features, again, like the model tends to classify whether the lung nodules detected are cancerous or non-cancerous, and this result is given as output by the machine learning model. So, according to the general architecture, we have tried to keep the process as simple as possible by using the segmentation methods and the feature extraction algorithms which are there, and the lung nodules are extracted, registered, and identified, and they are classified according to the severity. So, this table includes the detailed description of the techniques for the existing systems, and each of these systems will be discussed in analysis later on. Now, next up, I'll be talking about the data set which we will be using. The dataset which we have used is the LIDCIDRI dataset, which consists of 1018 CT scan images, and these images are provided by the academic centers and medical imaging companies, and all these images have been taken with the consent of the patient, and the data set was formed with these images. As we can see, like, the data set is a little small if we were to consider with respect to the learning algorithms. So in this data set, like, each CT scan images includes like four seasoned thoracic radiologists annotations on the lung nodules, and we have the DICOM images of the chest CT scans, and in this data set is further split into training, validation, and testing dataset, or training and testing dataset, depending upon the algorithm which is being used, or depending upon the way researchers want to continue with the process. Because the data set is very small, it is very much possible that the features may not be extracted properly, and it's possible that the model might go underfitting because of the small data set. But these are certain problems which have been addressed later on in the analysis of the papers which are going to be discussed next. Thank you. Hello, my name is Ashish, and I'll be covering with the analysis of research papers based on the approaches used. So, from the paper one, which is proposed by Sonia Marquez and the team, this paper focuses more on the classification of lung nodules based on malignancy, and combines the characterization and classification of the CNN technique. This paper emphasizes thoroughly on the comparison of several models which they have brought, which are being used these days. Uh, this paper revolves around the most common techniques or the algorithms which are there, which does include the CNN technique, and that's the first paper which we had chosen. Now, the next paper proposed by Prasad Dutante, it focuses on the 3D cascading of the CNN technique, which is like a video identification method. If I were to say, it's like a robust, like a video, it's like a robust system for video recognition. So, as we know that we're trying to recognize if the nodules which are present are cancerous or non-cancerous, this can help us in that, because we're considering a video analysis in this rather than considering a CT scan image. So this is like a different approach, as we'll have to go along with volumetric analysis, and this is like a deeper analysis of image, because we have like a series of image of the same person rather than having just one image through which we have to identify. So that includes more amount of processing and improved detection and learning for the model which we have. So this model tends to perform better and gives more insights as compared to the previous paper which we had researched upon. um, Moving on, the next paper which we have is proposed by Dondogu and the team. So this paper examines the standard and the traditional deep learning techniques for detection, segmentation, classification, and identification. This paper focuses more on the seed point image processing, which is like this is an image processing technique which is unique, and it's uh, because it's based on user criteria. Like we have certain criteria, like based on which even doctors say that the tissue or the nodules which are present are cancerous or non-cancerous. So these are human defined and defined by the experts. So these also help us focus on the errors during the process, which could reduce the performance, because the algorithm focuses more on the user criteria defined. So this helps us check if the criteria defined is correct or incorrect based on the model's performance, which indeed helps us improve the criterias which could help in other algorithms as well. So that's one of the unique points if I were to consider for this paper. And this paper focused more on this image processing technique rather than deep learning algorithm. For the learning aspect, it used the CNN algorithm. So next paper we have is proposed by Chufang Jeffrey and the team. So this paper focuses on the RECIST method or the recommendation index. The RECIST method revolves around like the response evaluation criteria in the solid tumors, which is like a set of published rules defined when tumors in the cancer patients tend to improve, or the patients remain in the same stage, or the condition of the patient tends to become worse. So this paper helps again, like the previous one, like in seed point analysis we had discussed, there was a user criterion. So over here also we were focusing more on the tumor's condition, so which is like over a period of time, which involves a greater amount of learning and analysis, because this will help us monitor the patient for a long term period, because we want to know whether, like, we obviously want to know whether the tumor is cancerous, nodule is cancerous or non-cancerous, but we also want to know if the condition of the patient would deteriorate over the time or will it improve over the time. So that is one of the unique aspects which we really need to take into consideration, apart from knowing whether the person is suffering from lung cancer or is not suffering from lung cancer. So this paper brought in like a very important aspect which the doctors also suggest, because cancerous patients need to be monitored at a very regular intervals of time, and also for longer durations, so that we can even find out if the cancer is spreading or not, because if it is spreading we know that it could be fatal. So this paper also made an attempt to recreate and quantify the amount of CT lung nodules to boost detection. It focused more on image processing, block detection, and extraction, just like we have discussed in the previous paper. And this paper even obtained higher sensitivity results. So this paper was able to give us very valuable information, which does require a lot of thinking over a longer duration of time. If we move on to the next paper, we have the paper proposed by Yufu and the team. This paper presents only the binary classification studies conducted, and this was because of the limitation of the data set as per the analysis. So the insights suggest that there is a new data set which needs to be created. Like we have discussed before, there are papers discussing about the video analysis for the CT scans of patients. We have the CT scan images, and if we were to consider the common data sets, even the data sets are very small as compared to the requirement for the algorithms in deep learning. So this paper focused more on the deep learning architectures with sophisticated image processing techniques, which is like harder to compare as compared to other papers. Also, they faced like a major problem for the data set, which limited their analysis and working on solving the problem and identification, resulting in lesser accuracy. Even though they created like a new model and the accuracy was on par as compared to the other models, but still it needs to be checked on the newer data sets which we need to create and work upon. Next paper is discussed by Leon Chan and the team. This paper focused more on the ReLU cascaded with the FPN to detect the nodules using single scale feature maps. Now, this paper gives us another important aspect, which involves distinguishing the pulmonary nodules from the background of the lung field. Now we know that we have some of the image processing techniques or learning techniques. We tend to see that we want to focus more on the nodule, but we also need to keep into consideration the background, because it's we don't want the learning model to get confused with the background, as it's like for, let's say, the images or even for the video feed, because if the learning model gets confused in detecting and identifying the nodule, or the area covered by the nodule, or the volume covered by nodule, then it could even lead to wrong results by the model. So this paper focused more on two detection networks, which is the artificial intelligence lung image analysis and lung field segmentation and registration. So basically, with the help of this, we're able to identify and register all the nodules and keep those in the learning stage, so that the model is able to distinguish the area better. Because mostly, if we were to see the dataset images, we mostly have like a black and white image. We cannot really obtain a colored image of this, or image in some other format, because we are limited in technology as of now. So this fairly limits the uh, learning for the module as well. So this is an important aspect which we need to take into consideration while developing further models, because the cancerous nodules could be very small, which may be hard to detect for a model until and unless it is trained well on a bigger data set as well. So we have major problems in terms of data set, which was discussed in the previous paper, and this paper talks about identification of such nodules from the background. Next up, we have the paper proposed by you and the team. So this paper focused more on the renowned deep learning concepts, and discussion was made on multiple database systems. As we had discussed in one of the previous papers, it was difficult for analysis because they were not having enough data set. The data set was very limited. So this paper really discussed on several database systems which could be brought into consideration, and we could club several datasets together and define certain criteria which can help us make a bigger dataset from the existing dataset, because it is difficult to compare large number of methods with the discussed ones with the previous research papers. We This paper was focused more on the database systems. Now, from the discussed list of algorithms which are presented in this paper, the model of 2D CNN with the PSO has given the highest accuracy. Now, moving on to the next paper proposed by Spurti, Rakesh, and the team. This paper discussed two major algorithms, which are the cuckoo optimization algorithm and the active contour algorithm. Now, the cuckoo optimization algorithm is used for continuous nonlinear optimization, and the active contour algorithm is a segmentation algorithm, which uses the energy forces and the constraints to separate the pixels of interest from a picture for further processing and analysis. Now, this is a very important aspect because, as we had discussed in the previous paper, we need to consider the background of the lung segment also into this, because we don't want the nodules to be confused with the background of the lung, because if that's not taken into consideration, then even the non-cancerous nodules can be confused with the cancerous nodules, and if we have certain denser areas in the images, we do not want the model to get confused with those areas with the cancerous or the non-cancerous parts, because that will lead to wrong results. So this algorithm really helps in distinguishing those areas. It helps in registering those areas, which can help in further analysis and learning of the model. Now, these algorithms were used with some other segmentation techniques, which is region growing, Otsu thresholding algorithm, and the Canny differential operator. Now, according to the Otsu thresholding algorithm, it involves iterating through all the possible threshold values and calculating a measure of spread for the pixel levels of each side of the threshold. And if I were to consider this algorithm, it's very important because using it with the active contour algorithm does give improved results as compared to the other algorithms. So, this is one of the important strategies which could be brought into the future studies and for the implementation aspects, as it is able to cover the aspects of both separating the background segment with the nodules. It involves checking the threshold, and it can even help in the volumetric analysis when we are registering the nodules with respect to the non-cancerous areas for the image which is being discussed in the dataset. Now, next up, we have the paper proposed by Mehdiya Starkey and the team. Now, demonstrated a dual pathway deep neural network for classification using a de-identified picture data. Now, dual pathway architectures have outperformed the traditional single pathway CNN. The paper also discussed a lot on the errors which could be made in the learning. So, this is an important aspect which the other papers have rarely taken into consideration, as they focused more on the image processing techniques and finding out the important criterion by which the nodules could be found and registered. So it's important for us to deal with those errors, because if we are able to reduce the errors, then we can think about ways to make on point calculations in learning, and the model will be able to perform better, especially if we were to reduce the error faced in the previous paper which we have just discussed. Now, next paper is proposed by Speaksha Jain and the team. Now, it focused more on the SALP shuffle with Shepherd optimization algorithm, which was implemented with the GAN's deep learning algorithm. These two happen to be very renowned algorithms in use. Now, the Triple SOA algorithm is a hybrid optimization algorithm, which is like a combination of both the Salzburg algorithm and the shuffled shepherd optimization algorithm. This algorithm, if we were to say, it's a single image processing and optimization algorithm with a deep learning architecture which was able to achieve an 86.34% of accuracy, which is like the highest accuracy we have noticed with a single algorithm, single optimization algorithm and a single deep learning algorithm, where compared to the other papers which have discussed a combination of certain algorithms to improve their results and achieve higher results. So if we were to use such algorithms, then it's in the future studies and references, it's possible that we can improve our results and create better systems and learning models which could be used. Now, these exceptional results were because other papers had the multiple algorithms in combination, where because the researchers here had focused on a single algorithm, and we can say that this was a good attempt to find one of the best image processing and the learning algorithms which we can have. Next up, we have the paper proposed by Dio Wong and the team. Now, this paper reveals that the best classification outcomes come from the segmentation map as a mask to remove the interference information surrounding the CT volume, and this would involve the quantity of the nodules which are being used, which are being taken into consideration for the learning of the models. So this paper offered a cascaded architecture which combined the training for segmentation and the classification models. The next paper is proposed by Syed Faz Ashraf MD and team. Now, these ML systems show the reasonable performance in discriminating the benign from the pre-invasive and invasive cancer. Now, the accuracy in this prediction differs between the subtype of the nodules. So, this paper discussed further into the types of the lung nodule cancers which have been identified, and the results could be more accurate and could be improved if the models could have a higher more amount of data to learn on. As we discussed, the data set in this was smaller as compared to much needed data set, because in this we are trying to find out which type of cancer the patient is suffering from, rather than just identifying if the patient is suffering from cancer or not. So this does involve much more specific processing, because if we were to consider the diagnosis for these, there could be a difference in the diagnosis, and if we identify the wrong type of cancer in this, then it could lead to wrong diagnosis and it could be fatal for the patient. So the paper needs to be reviewed further for the processing which it will need if we have a much deeper data set as discussed in the papers before, and the model can be considered as a good approach to step forward into the future works. If we move on to the last paper which we have, it's proposed by Alberto Ray and the team. Now, this model used in this was designed to operate autonomously using the soft computing techniques. If I were to point out these techniques, this is like one of the very few papers which discusses on the other algorithms apart from the deep learning algorithms, and this does bring in certain concepts about fuzzy logic and certain algorithms, because detection because there are many papers which discuss upon the image processing techniques and the learning techniques, which are very specific. But when it comes to certain areas in the images, it's very much possible that the model can get confused whether it needs to take into consideration for that area or not. Because if we were to zoom into the borders of where we have the nodule, so it's very difficult for us to figure out whether it belongs to a background, the lung background, or it belongs to the nodule. As we had discussed in the previous paper, like in which the algorithms were discussed, which were efficient in separating the background with the nodule, this paper can be really considered into sync with that research, because it can really help in classifying those certain areas around the lung nodule, and can help in the quantity analysis. It if we were to go very deep into the analysis for the images or the data, this the quantity could differ with respect to the pixels which have been taken into consideration or not. So this data, the data set used in this was taken into consideration from several diverse data sets, which does solve a problem as discussed in one of the papers before. So this paper does give a lot solution for the future work, and solution to the problems which have been discussed before. Next, we have the summary of all the methodologies discussed in these papers. It involves all the image processing techniques and the machine learning and deep learning algorithms. Uh, in this, along with the results which have been mentioned in the papers. Next up will be coming giving the conclusion and the future work. Just to summarize everything from the papers, there are several algorithms for image processing technique. If we were to say, there are much more number of image processing algorithms as compared to the machine learning and the deep learning algorithms. If we were to consider the algorithms, mostly all the papers discuss this very common algorithm, which is CNN. Apart from these, the machine learning algorithm which has been discussed a lot about is the SVC algorithm. So the even though we have like a large number of machine learning and deep learning based algorithms, it is very important for us to consider the image processing algorithms, because at the end of the day, the more efficiently we can process an image and give it to the model to learn, we can have more efficient systems, and we can build more efficient systems and even improve the efficiency of the existing systems. Because the model, we can tune the parameters also to a certain extent only. At the end, it will sometime come down to how the images have been provided to the machine learning model. So if we were to talk about one future work, it's analysis of the image processing algorithms along with the machine learning and deep learning algorithms, and not just the learning algorithms which we have today. This can help us in better analysis, it can help us provide better results, and it can help us save more lives. Thank you.
This paper reviewed existing approaches for lung nodule detection and diagnosis using CT scans and presented a framework for the development of machine learning and deep learning algorithms. The analysis indicates that no specific model can be said to stand out, in part because of the variations in the image processing methods employed by researchers. The usage of CNN in conjunction with any machine learning algorithms does share one basic notion though. This demonstrates the concept's broad applicability and adaptability, which not only contributes to the enhancement of its own operation, but also has a significant impact on all other algorithms. We can also notice that the areas that require more research are the image processing techniques. According to the research papers considered, it has been discovered that how the data image is preprocessed has a significant impact on the performance of the learning models. If the images are preprocessed effectively, learning can be significantly enhanced because the models will be able to extract features in a useful way. The implementation requirements make it challenging to classify both learning algorithms and image processing approaches.